Ok, va bene.
Problema?
No, per niente.
Okay. Hello, everybody, and thank you very much for joining us tonight. The meetup of tonight is going to be on how to speed up data preparation for machine learning pipelines on AWS. Before we start the tech talk, let me give you a brief introduction to our community. We are an independent group that was founded on February 2016. We're a technical community boasting more than 1.7 thousand members on Meetup, plus I would say same amount as much on other channels. So it's roughly should be around 3,000 members nowadays, and we meet every month on. We used to meet physically, and right now we do all of our events online, like this one. We are part of a larger association that is the Italian Association for Machine Learning, and the staff is formed by the people that you see in this slide. And we are always looking for volunteers who wants to join the organization. And in particular, we're looking for a social media manager at the moment. So in case you want to learn more, then you can get in touch with us. This is the event of today. And yeah, all of the information about everything that we will organize in the future and all the previous events is on our website, www.datasciencemilan.org. You will find the recordings on our YouTube channel and the presentations in our SlideShare account. You'll also find on me This is another service we offer to our community members, is the monthly digest. We only send you one email every month with all of the relevant articles and events that we have selected for you. And again, you can join the digest from the website. If you want to keep in touch with the community members, we use Slack as a main channel for communications. And yeah, you can find not all of the members, but a lot of them, you can find them 24 hours every day on Slack. And if you want to send your proposal for next tech talk, you can send it to datasciencemilan@gmail.com. Let me share with you some of the news and the openings from the community. There is MediBio, that is a digital medicine company focusing on mental health that is looking for a senior data scientist specialized in machine learning. And this is a remote opportunity for everybody located in a European time zone. You can go to medibio.com.au to find more about this role. Limited Bank is also hiring in Milan a data scientist position. Qubit, it is hiring a data engineer. It is based in Milan, but it is also offering a remote opportunity. Coveo is also hiring data engineers, again, both either based in Milan or remote opportunity. And Brainly is also hiring. This is not based in Milan yet, but it is hiring in Krakow, Barcelona, and remote opportunity. This is the company I work for. And there are a bunch of roles from data scientists, machine learning engineers, and MLOps. Let me give you some other news from the community. The Academy of Deep Learning Italia is looking for tutors and teachers for the e-learning platform. And if you instead are interested on taking the courses they offer, we have negotiated a special coupon where you will get 60% discount. This is a limited time offer only. So in case you're interested, then I recommend you to use this coupon as soon as possible. Let me show you some of the conferences that are happening in the next couple of months. There is the European chapter of the Association for Computational Linguistics that is happening 19th to 23rd of April. There is the Developer Week, which is happening on the 27th and 28th of April. And we have a special deal where we can get 50 euro discount for the Open Pass that normally would cost 85, so you will only have to pay 35. And this is only for Data Science Milan community members. Another relevant event is the Google I/O conference, which is going to be at the end of May. Yeah, and this is it. If you want us to publish any message in one of the next event, you can send us your correspondence. We'll publish in the wallboard. And the agenda for today is we have Francesco Morelli, who is a senior solutions architect at AWS, and he will lead the the talk for tonight. Before we start, we need to ask you a favor. We are a group of volunteers, so we do this because you're passionate about spreading machine learning and data science knowledge. In exchange, what we ask you is to like us, follow us, and share. Spread the words, share posts, mentioning us, pictures, whatever you want, such that we can build our reputation on social media platforms. Thank you very much, and enjoy the event of tonight.
Okay. Hi, everyone. So is my screen shared? Hello? Okay. Okay, can you see it full screen? Okay, thank you very much. Okay, thank you.
Probably,
okay.
Fabio, can pin the screen.
Okay, thank you. Okay, so hi everyone. My name is Francesco Morelli. I work as a senior solutions architect at AWS. I've been working here for about 2.5 years now, and I've been working with data in general for quite a few more years. So today we'll go through AWS services for data engineering, data manipulation, and in general for data preparations for data engineering and machine learning pipelines. So for you today, I have a few demos as well as some slides and some information that I hope you find useful. So before we start, I just want to introduce to you the lakehouse approach. So basically, how AWS sees the data platform in general. If you've been working with data for a while, you know that previously there were data silos. So the data was actually isolated, and it was difficult to analyze and to have an holistic view of the enterprise data. And the evolution of data platforms went from standard data warehouses, went into big data, so the adoption of Hadoop platforms, and that led to the data lake concept. So what's a data lake? A data lake is a central repository of data upon which different analytic services that are used by different analytic services. So on top of the data lake, we have big data processing. We can do log analytics. We can do data warehousing, for example, and we can also have a non-relational database and relational databases. And of course, we can perform machine learning, so which is pretty much the focus of your user group. So the lakehouse architecture on AWS it's a concept, is an approach that allows you to build scalable data lakes and analyze the data using purpose-built data services. And what's really important is that this data has to move from one service to another, so coming from the central repository, and we need to exploit and to use the data using different use cases. And all these has to go through a unified governance and has to be, of course, performant and cost-effective. So as you can see in this slide, this is our approach. Have one central repository of data, which is usually implemented using Amazon S3, our object storage service. We have one analytics service called Amazon Athena that allows you to query the data in place on S3 as soon as the data lands without any data preparation. And around these core services, we have AWS Lake Formation, which is a governance and security service, as well as AWS Glue. We'll focus quite a lot today on AWS Glue because it's the service. We'll see it's a service with many, many features that allows you to prepare the data and to wrangle data. And around these core services, we have different analytics services. So for example, we have Amazon EMR, which is our service for big data. So it's managed Hadoop clusters, and Amazon Elasticsearch service. If we look at the same picture, but from another view, so basically from when the data is ingested into the data lake on the bottom, so we have the data movement. We have different layers. So we have data movement, we have different services to do data ingestion. We will not go through all these services because it would take quite a long time. Then we have services for data lake infrastructure and management. We have already seen S3, Lake Formation, and Glue. And then we have analytics services. Each analytics service is satisfies different purpose, different analytics services, analytics needs. And on top of that, we have different data visualization and engagement and machine learning services that allow you to actually use the data and get value from the data. If we look more closely to machine learning services, we really have many services for machine learning. Again, we have a stack. At the bottom of the stack, we have frameworks and infrastructure, as well as compute resources to actually ready to perform machine learning. On another layer, we have what we call the machine learning services, in particular Amazon Sagemaker. Amazon Sagemaker is a service that contains different features. We'll see a couple of them today, that allows you to orchestrate machine learning and artificial intelligence pipeline from end to end, from data labeling to inference. And on top of that, we have different AI services that are called basically just using an API. So for example, we have Amazon Recognition for Vision. We have different services for speech, such as Amazon Poly and Transcribe, Amazon Comprehend for text, and many others. So we really have a full set of services for every need. What's really important in this is that every kind of machine learning practitioner, from the experienced one to the novice, can find a feature for their experience. And Amazon SageMaker in particular is built to make machine learning, to make it more accessible. And we release SageMaker Studio ID, the integrated development environment, which is your single pane of glass for all machine learning activities and tasks. Okay, so after this introduction, we start, we have a look at Glue. AWS Glue, and AWS Glue is a serverless data integration service for complex workload. What's really important is that this is serverless. With Glue, you don't have to provision any infrastructure, you don't have to maintain any infrastructure, and it's really important. This allows you to allocate only the compute that you need to run your jobs, and that's really important because it makes it very elastic, very flexible, and also allows you to pay only for the computation, for the resources that you need. As we see, Glue provides different features and allows every user to actually perform data integration, every user with different skill sets. So we go from the experienced data engineer to data scientists who are used to writing code, for example, in Python or Scala, and to data analysts that have no experience in code with code development. It's very cost effective. And it can handle complex workloads. It can process petabytes of data, say in batch, so at rest, but also streaming data, so real-time data. So you can get value from your data as soon as the data enters your data platform, your structure, and your applications. And of course, there is no lock-in. We use open source services and projects, such as Spark, and you can write your code in Spark SQL, in PySpark, and Scala. So you can actually bring your code to Glue, and you can also take it out of Glue and run the code that you develop there in any other environment that runs Spark as an engine. So how customers use AWS Glue? Glue is born as a data integration tool, so its main focus is to process data, so we can build data lakes and lake houses in a very scalable way. We process loads of data, and one of the very important features is that we see many users migrating to Glue from traditional expensive ETL solutions to reduce cost. Of course, Glue can actually be used to prepare data for machine learning. And Glue also provides a data catalog, which is very important. We'll see it later. A data catalog that becomes your central metadata repository for your lakehouse and for your data platform implementations on AWS. So as a data integration platform for building data lakehouses, we can see a standard pipeline. So from ingestion, so you can connect using Glue, you can connect to different data sources that can be software as a service. So for example, Salesforce, Google Analytics. You can connect to standard relational database through JDBC and ODBC. So Oracle, SQL Server, our own Amazon relational database services, or Aurora, for example. The data can be either in your on premises or in your own data center or in AWS already. And you can also connect to streaming data. After you connect to the data using connectors, Glue gives you a very nice feature called Glue Crawler. Glue crawlers allow you to discover and register schema inside the data catalog. This is very important because we see customers with millions of different data sources, and you can imagine how hard it can be to actually create schemas and catalog each single table or data source. So Glue Crawler make this work very easy. Of course, you can catalog your data manually using APIs or with different other ways, but we see crawlers as a big enabler for lakehouses on AWS. The data catalog in the Glue data catalog can be structured or semi-structured, so we can have standard tables, standard tables, but you can also catalog data which is in XML or CSV or JSON format, for example. A part of the data catalog is what we call the Glue schema registry. That allows you to catalog streaming data sources very, very conveniently and very easy. And then with Glue Studio and development endpoints and Glue DataBrew, which we'll see more of later, you can transform and you can actually use your data. And all this goes into the lakehouse approach. Once your data is processed, you can actually use it in many different ways. This is just one of the examples. So it's how you can use Glue to modernize on-premises ETL tools. So it's a standard pipeline from end to end, from ingestion to exploitation with business intelligence tools. And of course, you can use Glue to prepare raw data for machine learning. So you can connect to your data sources. You can use Glue development endpoints, for example, with notebooks to do data exploration and do data experimentation. And once the data is enriched and processed the way you like it, then you can catalog it again, and then you can extract features, and you can have training data that you can feed into your machine learning models that you're developing, either with Sagemaker, for example, or that data can actually become the input for other services that are based on AI and ML, such as Amazon Forecast, Amazon Comprehend, Amazon Recognition, for example, or Amazon Lex. So Glue really becomes the enabler for all these kind of workloads. This is just a quick recap of the Glue components. So with Glue, you can do, of course, ETL in a serverless method. You can also do workflow management, so you can build and orchestrate workflows of ETL jobs, and you can catalog the data. And again, you can crawl using crawlers. You can crawl the data. So it's a very comprehensive set of features. To go back a bit on the central lore of the data catalog, with the Glue data catalog, as you can see from this image, Glue data catalog becomes the intermediary from all the transactional data system, data warehouses, so all your data sources are actually cataloged into the Glue data catalog, and data services such as Redshift Spectrum, for example, or Amazon EMR for big data processing, interactive workloads with Athena, or real-time data with Kinesis firewalls or Kinesis. I can actually interact with the data catalog, as well as machine learning services and business intelligence services like our own Amazon QuickSight. So really, the data catalog is the central element for our data platforms. Glue workflows can be implemented in different ways. So you can have triggers. You can have which are based on a schedule. So depending on the time of day, for example. They can be event-based, but can also be on-demand. So workflows can be triggered based on event using our own Lambda, Amazon Lambda service. And with workflows, you can implement very complex pipelines if you need. We just released the version 2 of the Glue engine. The Glue engine starts very quickly in seconds, whereas before it used to take it could take quite a few minutes. So it makes developing and testing also jobs much easier, and you can implement diverse workloads, which are both for real-time data and batch data. Okay, and again, it's very cost-effective because you only pay for the resources that you use, and you have 1 minute minimum billing. So it's really cost-effective compared to standard tools. You can connect to pretty much at any data source that you can think of. These are just some examples that for which connectors are available already for Glue. But what's really important is that you can actually build your own connectors. So, for example, if you have on-premises DBs or even on-premises APIs that don't have a connector ready, you can actually with Glue build your own custom connector and make it available to the service in your account. So Glue satisfies the needs of different personas. So from the data engineer to the data analyst to the data scientist, analyzing different kinds of data, which can be streaming or it can be batch. So in this slide, we see some of the features. We see Glue Studio. Glue Studio is a visual ETL IDE for the non-Spark experts. So it allows you to write Spark code in Python or Scala using a visual interface. We'll see a demonstration a bit later on. You can also develop jobs using development endpoints if you know your code and if you want to write the code and if you want to really go down to optimizing and go down to the low level of coding. With Glue Studio, you can also develop codes on streaming data. So it's really interesting because you can actually develop jobs that continuously running and continuously process the data. There's another feature, not yet in general availability, but will become by this year, I think, called Glue Elastic Views that allows you to replicate the data across multiple data stores without code. So you just specify the input source, the destination source. So for example, from DynamoDB to S3, optionally specifying some transformation rules, and then the Elastic Views run continuously to replicate your data. And of course, we have Glue DataBrew. It's a new tool, very nice tool. We see a demo later that allows you to build the data without any code at all. So Glue Studio is a new visual ETL interface, and it makes it easy to auto-run and monitor AWS Glue ETL jobs. Again, without any coding, although you can plug in your own code if you need to. You can also, there's also a very nice monitor feature that allows you to see how your jobs are you can monitor your jobs through this single interface. And you can implement jobs that have distributed processing. So very complex jobs without actually having to know how to develop these jobs. And you can also have advanced transformations using code snippets. So you can actually import your own code and basically customize Glue jobs the way you like. Okay, so we'll just just give you a quick demo of Glue Studio. Okay. Okay, so this is the interface of Glue. There are different features. We will not go through all of them because it would take quite a while. We'll go direct to Glue Studio. And this is the main page of Glue Studio, and we can go directly to the jobs. Okay, I've already developed one job for you to speed up the demo and the presentation. So what you see here is the pane where you actually develop the job. You can actually have data sources of different kinds. So in this case, we are using two data sets which are the input of the process. One is related to COVID information, and it's a CSV format in S3, and the other one is in CSV format again on S3. As you can see, this data is actually already cataloged into the data catalog, the Glue data catalog as a Glue data catalog table, which is organized in databases and tables. For the COVID data, we apply a mapping, so we drop some tables. You can change here. You can change the types of data, for example, just by selecting a target data type, and we also drop some columns. And what we do straight away from this apply mapping, we actually save the same version of the data, but in another format, which is the Parquet format, which is a columnar format optimized for analytics workload. So we save a new version of the data, again in S3, so we provide the path. And while we do that, we also register the table into the Glue data catalog. So the first step, the first output of this job is this COVID data set in Parquet format. So if we go back to Bitcoin, again, it's a CSV file. We do a transform. We call it remove time. In this case, we have developed a Python job that actually removes the timestamp from the data information that we have. So we can see in this case, this is a custom transform. This is a utility transform that allows you to select the output table that we want to save, and then we save the output again in a Glue in Parquet format onto S3. So as you can see, the transform can have more than one output, and we use those two outputs to join the data, and we do a left join on a date, which is in the COVID data set, and we then use the new date only column. So we do a left join on these two columns, and we save the output of this data onto S3. Okay. So apart from this one that we added for demo purposes, we see that this transformation was done basically completely visually. So what are the elements? The elements are source. Source can be S3 or DS spreadsheet. So you have different sources that can be the output of the transformation. You can have transform. You can have custom transform, apply mapping, select field, drop field. So there are many transforms that you can play with. What's interesting is that we also have a Spark SQL transform. So the transform that we wrote this way using basically Python. You could also use the SQL, Spark SQL to actually develop it. And then we also have target. Target can be a data set in S3 or can also be a data set in the Glue data catalog. Once the job is developed, the Python script is actually generated. This is the script that is run in the when the job runs. Okay. Okay. So we have different job details. So these are the details, technical details of the job. So how many resources we want to use to run the job, as well as some advanced properties such as where the logs are saved and all that. So you have complete control on the execution of your job. I've already run this process a few times. So for each run of the job, you can actually have some details. You can actually go to CloudWatch and you can see the logs for each job run. Okay, so this is the data at the job level, and you can also schedule the job. I don't have one at the moment, but you can definitely do it. Okay, so we've seen the editor. This is the jobs. This is the monitoring. So for the monitoring, we have, of course, I just have a few runs. Some of them failed because I had a missing permission on one of the target locations, but eventually the last one ran successfully. What's interesting is that you can click and you can actually see the one that ran, and you can see the details, okay? And you can actually see the run details as before. Okay, so quickly, this is how you develop jobs with Glue. Just one thing I wanted to show you is the connectors that we talked about earlier. You can actually import connectors into your own account, but there's also a marketplace for connectors. So some connectors are actually free to use. Some others are provided by third parties, and you can actually buy them and you can use them in your jobs. You see there are many, many different connectors, for example, for Google BigQuery, and for CloudWatch, for Elasticsearch, and many, many others. For Hoodie, so if you have a transactional data lake, for example, and many, many other, JDBC, Salesforce, Couchbase, so you can really import loads of different data sources. Okay. So if we go back to the presentation, so we're seeing that even with Glue Studio, you can actually go down to the code level. But what we see is that some customers complain that their teams spend too much time on the undifferentiated, repetitive, and mundane tasks associated with data preparation. So some people don't actually like doing data preparation, and they want to do it as quickly as possible without code. Because we all know that preparing data involves several complex tasks, such as ETL, cleaning and normalization, and orchestrating jobs at scale. So we need a lot of code-based and heavy lifting to work at scale. And also, we have different personas now using and preparing the data. So we have data engineers, we have ETL developers, which might have a good technical knowledge and know how to develop code and how to orchestrate and how to engineer data pipelines. We also have data analysts who just want to analyze the data without thinking too much and too long about how to prepare it. And we also have data scientists. They might just want to do some data analysis and just create features for their machine learning and data models. So typically challenges with traditional data preparation can be manual, can be siloed because they can require moving large amounts of data into silos before they can actually get benefit from the data. And of course, it's time consuming and it's a process that requires experience. So to overcome these obstacles, we have introduced AWS Glue DataBrew. Glue DataBrew is an interface that allows you to do data preparation without any code. Okay, we'll see a demo shortly. It's a tool that's built for data analysts and data scientists. It allows you to understand data quickly with data profiling, for example, which is very, very useful. We can clean and normalize data using more than 250 built-in transformations without any coding. And we can visually map data and lineage. So we can actually see how the data is used and the progress of data through data pipelines. And we can automate at scale very, very easily. So data preparation made easy through DataBrew. Okay, so I can show you a demo of, okay. So we can go, okay. Okay, we just made it. Okay, so this is the interface of Glue DataBrew. Glue DataBrew works on four concepts, on four concepts. So dataset, projects, recipes, and jobs. Okay. So what you can do, you can define one or more data sets. So for example, I'll define the COVID states daily data set. So this is the main interface, just to show you. You can connect to a new data set and you can create a data set. The data set can be already cataloged within the AWS Glue catalog, can be on JDBC, can be accessed through JDBC connection, Redshift, S3, Data Exchange, which is a service that allows you to exchange data between accounts in AWS. So in many different ways. And it allows you even to parameterize the file names if you go through, if you use S3. So you can actually do some very neat data loading and data definition for your data sets. I've already created one for which is on S3. When you define the data set, in this case, you don't have a preview because it's a zip file, but you can have an overview of your data. We'll see later. So basically what I've ran a data profiling job. I've already run it. It's something that you actually have to run. And the data profiling job actually gives you some very nice information about how many columns you have, total rows, and the type of columns, of course, the correlations between columns. So that's all done for you. By default, it gives you all the columns, but you can also select which columns you want to analyze for correlation. So without any code, so that's really, really useful. And you can have a value distribution for each of the columns within the data set. And for each column, you have all the properties we related to data quality, distribution, minimum, maximum, how many missing values there are, distinct values, and all that. Okay, so it's really, really, you can really go down into detail, and that's all done for you simply by running a profiling job within DataBrew. And you can split by string and other column types when you analyze this. Okay, so this is a high-level overview of the data, but you can also go into the column statistics. And for each column, you see you can select your column. And for each column, you have different information, really, really detailed, okay? And without any kind of code. So this is really useful to profile it, to understand your data. And also you can do data lineage. So you can see how your data set is used to within your data pipeline. And you can also look at the log to see who actually used your data set within DataBrew. So this is the data set. What you can do, you can also define a project. A project, you can see basically the project as a logical container where you define how you want to transform your data. So when you go into the project, you actually have a sample. You can see it says 500 rows. You have a sample of your data and you see statistics based on your sample. And what you see on top here are all the transformations that you can perform on your data. So you can split, merge, create, you have functions to transform your data. So there are more than 250 of these overall. You can unnest your data, pivot your data for strings. You can, for example, clean, you can format your data. So really many transformations. And you can do that for each column. So basically what happens is that when you actually create transformations against columns, you build what is called a recipe. As you can see here, a recipe is a sequence of steps that transform your data. I've already created one here. So for example, I've changed the type of the date column to string, whereas before it was an integer. I have created a duplicate column, I've split some columns, I've done a field missing, so you can build your own recipe actually without writing any code. Once your recipe, once you are happy, and step by step, what you do when you create steps for the recipe, you can actually preview what's happening within the data. Once you're happy with the result, you can publish your recipe. I already published one version. I can publish a second version, for example. And the recipe is published, okay? So you see this is version 2, and you can actually navigate time travel to the different versions that you have, just showing you the current version first. Once your recipe is ready, it's published here. Okay, so this is a more detailed version of the data. And then you can create your jobs from your project. So you can actually execute a recipe on a data set as you define in the project, and then you can have your jobs. Okay, so this is one of the jobs I ran. And I ran it a couple of days ago for this demo. So basically, it's a way to operationalize data manipulation and data processing without writing any code. Okay, and again, you have job titles and you can data lineage for this job. And you can also create schedules for the jobs again. So very, very easy to create data processing with Glue DataBrew without any code. I didn't write any code. I just wanted to show you that, for example, so if you go here, there are some transformations, for example, one not encode columns for the specifics for machine learning and preparing data for machine learning processing, categorical mapping, and so on. Okay, so if we go back to the slides. So what we saw in the demo, we see in data profiling, how to build the recipe. The recipe was actually built already because it might take a while, obviously. We're seeing customers building a recipe with more than 200, 300, 400 steps, which is really good and gives you an idea of the power of the recipes that can be built. And of course, we can run a job, and then we can operationalize all these tasks at scale. Okay, what's really interesting is that recipes can be used. So the recipe, you can see the recipe as your code if you like, and of course you can apply it on different data sets, provided they have the same structure. All these can be automated using our APIs, like any other functionality in AWS services, or using SDKs. So I'll go quickly through this. Some use cases for DataBrew. This is a standard case of data analysis for business reporting, for example, like standard Glue, standard ETL. Really interesting, you can do data quality rules with AWS Lambda. So something I didn't tell you earlier is that the output, for example, of Glue DataBrew profiling is actually a JSON dataset on S3. So once the profiling job is run, and it can be run on a periodical basis on a schedule, the results from the profiling operation is saved on S3. And once it's saved on S3, what we can do, we can actually run a Lambda that reads the results of the data profiling. And if there are some problems with the quality of the data, we can actually send a notification through our SMS service. And for example, we can send an email notification to a data scientist, to a data engineer, or we can use that event to start an automated process of data remediation. This use case is actually in one of our big data blogs. So if you're interested, it's really, really interesting, and it provides you with a full working solution based on this architecture. We can use DataBrew to do data pre-processing for machine learning. So we can create features to create data to do training, and then to train models. And of course, we can orchestrate data preparation in workflows. So for example, we can create workflows for jobs that read data from Redshift and then process the data, and then the output data is crawled using AWS Glue crawler. So just to say that DataBrew can actually be integrated, although it's its own, let's say, service or application, if you like, can actually really be integrated in any kind of data pipeline that you might think of. Okay. So we have another service for data wrangling, for data preparation, called AWS Data Wrangler. So what is Data Wrangler? AWS Data Wrangler allows you to use pandas, basically, with AWS services, okay? So I'll give you a quick demo later on, shortly, but basically, we know that we have different data sources. The data can come from different services, such as, for example, Spark, JDBC, relational databases. So these services can be AWS as well as on-premises services. And we want, it can be difficult to actually have a code set, a code base that allows you to integrate all these sources and process them in a homogeneous way, okay? So that's why AWS Data Wrangler was born. So it allows you to actually write processes using Python and using pandas, which I'm sure many of you are familiar with. So I'll give you a quick demo of AWS Data Wrangler. This is Microsoft code running on my Mac. Okay, so very easy. So it's a notebook. So for this, I'm using these libraries. Boto3 is the Python AWS SDK. Pandas, I'm sure you know, no introduction needed. And then I'm importing AWS Wrangler, okay? AWS Wrangler security and authentication and authorization is basically delegated to Boto3. And in this case, I've set up on my PC the AWS CLI. So I've set up with that a profile, which I called Glue. And in this case, I'm setting up a region as AWS West 1, which is our Ireland region. I run the cell, so this is just a setup. And once that's done, using Wrangler, I can actually query the databases within my catalog very, very easily. The return is a data frame. In this case, I'm just showing it to you. So these are all the databases within the account I'm using for this region, for Ireland. So I set the database to COVID Bitcoin. This is the name of the database, and I see the tables that are within the database. We can see that the data frame returned is this column database table, the description, the columns within each table, and if there are any partitions defined. What I can also do is I can see the details of each table. Okay, so these are all data wranglers calls that I'm making, okay? And now the fun part, what I can do with Data Wrangler, AWS Data Wrangler, I can run queries, for example, again, any service on AWS, basically any service. In this case, I'm running a query against Athena and just doing a simple query in select star from table. So I'm just basically returning the first 10 rows of the table, okay? Okay, all these on my Mac, so it's very, very flexible. This is just an example. Well, once you have your data in a data frame, and you can use it in pandas, you can use it any way you like. So these are the first 10 records returned, and this is a bit of a more complex query using not really complex, but just to give you an idea. I'm just running a query, just a summary table, a summary query against the database using Athena. So, okay, just running. And in this case, I'm simply running the query on basically over the internet. The connection is completely done over the internet. I'm not running any kind of private connection, so it makes it very, very flexible. So this is the result of the query ran on Athena and returned to my Mac. And what's really interesting is that once you have your data frame populated with the data, you can actually write back your data. You see this data frame, which is the one I created in the step earlier. I can actually write it back to S3 very, very quickly. And not only that, I can actually register the database, the output data directly onto the Glue data catalog. So very, very flexible. And after I do that, I can read again the parquet table in just a few lines of code from your PC, so in notebook. So really, really powerful. Okay. Okay. So I wrote parquet. I registered a new table within the Glue data catalog, and this is the data that I read back from the parquet files on S3. And just to show you that the table was actually registered, I'm just taking the details of the tables from the data catalog. And as you can see, these are the columns already registered in data catalog for the table we created in the previous query, which is this one. So very, very quickly, just wanted to give you a quick overview on how you can use AWS Data Wrangler. So very, very powerful library. It's all in GitHub. You can just load it, use it. There are many, many examples that you can use. Okay. Tutorials, introduction, you can have all kinds of interactions. It's very, very rich, very easy, and I'm sure you can start using it in a matter of just a few minutes. All right. So we're not done yet, because of course we have another type of data wrangler in AWS called the Sagemaker Data Wrangler. This is a feature that's quite new, and it allows you to do data wrangling, data manipulation from within Sagemaker Studio. It's quite similar in a way to what we saw with DataBrew, with Glue DataBrew. Some customers ask us what's the difference. The difference is that DataBrew, although they have very similar functionalities, DataBrew is more oriented toward data preparation from, let's say, an engineering or more general data preparation point of view, whereas Sagemaker Data Wrangler is more oriented towards integration within machine learning pipelines. Okay. So which are the use cases? We want to cleanse and export the data. We want to visualize and understand the data, and we want to enrich data. Again, we want to wrangle the data to make it useful for our machine learning processes. Okay, so we can query and we can select and query the data. Again, we can select data from S3, from Athena, from Redshift. Again, we have more than 300 built-in data transformations, and I'll just give you a quick demo later of this as well. And you can also author custom transformation with PySpark, SQL, and Pandas. What's really useful is that we can also analyze the data and understand the data visually to see if there are outliers in the data, for example. And we can estimate model accuracy very, very quickly. So we can have quick models, for example, to see how the data, which variables are most relevant to predicting the outcome of a given column with labels. And of course, we can deploy the data. We can, after the data is done, we can actually create. What's really interesting is that Sagemaker Data Wrangler can create a notebook for you with all the code that you can then actually use as a starting point for your own processes. So Data Wrangler is available now. It's priced per instance usage. So we pay for the instances, the EC2 instances that are behind the notebook for the usage. And it's available in all regions where Sagemaker Studio is available. So I'll just give you another quick demo of a Sagemaker Data Wrangler. So this is Sagemaker Studio, which you can access directly from Sagemaker. So Sagemaker Studio. I've already defined my username, so you can have more than one user. And once you open the studio, you have this nice interface, and this is your central point, your central IDE from Sagemaker that allows you to actually build your machine learning pipelines. So I've created, Data Wrangler creates an entity, let's say a project called Flow. And as you can see, there are different steps. There's the import, where you can import your data. So you can import data from S3. These are all the buckets that I have in my accounts. But you can also import data from Athena, or you can also import data from Redshift. In this case, I don't have a Redshift cluster set up, so it's there as optional. Once you import your data, you can prepare your data. I'll just go quickly through this. So in this case, I have this data set, which is a Titanic CSV. This is actually a data set that's already been prepared. And I can transform the data, okay? So I can add a transformation, for example. And you see, these are all the columns that I have, okay? And these are the transformations that you can create. There are custom transformations. There are transformations to encode your data. Categorically, you can create featureize based from date time. Sorry, I'll just make it a bit bigger. Okay, so just like for DataBrew, many transformations. As you can see, the categories of transformations are more geared towards machine learning pipelines, okay? So each transformation that you have is basically added in these steps. So for this example, I did create manage columns, drop columns. So for example, I dropped a couple of columns which were not required, such as the name of the passenger of the Titanic and the ticket number. And I've also created a step which is a process numeric to convert the type to create a new numeric column from the ticket fare. And then I also did an analysis. Analysis. Okay. So I've created histograms, so you can see you can create very quickly histograms. Okay, different types of analysis. And I've also created a target leakage analysis to analyze to see which kind of if there is target leakage, okay, on columns. Okay. And something that's really interesting is that you can export this data, and you can export it to processes in different ways. Okay. Okay, and by exporting the data, you can export it to that process that I created visually. It's actually exported as a notebook. So it's a standard notebook with all information, with the code, okay, that was created. And you can actually edit this code as you like. So you can just change your code. So this can become the starting point of your notebook or data processing pipeline, okay? Okay, so we go back again to our pipeline. I think that was all, just about 50 minutes, more or less. It was really quick. Just wanted to give you a quick overview of all the different services, and I hope it was useful. Okay, thank you very much.
Thank you very much, Francesco. That was really helpful for, I think, people that are using AWS and have not used these tools yet. They should probably give it a go. That was really inspiring. There are a few questions. I actually asked a few of those. I want to encourage everybody in the live on YouTube. You can use the chat embedded in the live video to ask questions, or you can ask them in the general channel on Slack. So I will start reading a few of those. And the first one is about the workflow management. In one of the first slides, you showed that Glue has the workflow management embedded as built-in. But then later you showed step functions as a workflow manager, and the question is, what should be the default choice for orchestrating jobs?
Yeah, I give you the standard wide we give at AWS, which is it depends. Okay, so workflows as Glue workflows are allow you to orchestrate workflows and processes within Glues. So it allows you to use Glue jobs, orchestrate Glue crawlers. They have their own scheduling mechanism, triggers. Okay, so it's a workflow, it's a Glue feature, if you like. Step functions are an AWS service that allow you to create general workflows, okay? So not just for Glue, but you can use step functions to orchestrate much wider kind of workflows. So for example, you can have applications that send events to a queue that then again sends some kind of other events, and based on different steps of the step function, you can then also kick off Glue jobs. Okay, so the short answer is that step functions allows you to orchestrate pretty much everything within AWS, whereas Glue workflows allows you to orchestrate Glue jobs and Glue data pipelines. Okay. What's interesting is that you can actually kick off Glue workflows from within a step function node as well through a Lambda. And yeah, so it's really, really flexible. Again, AWS provides you lots of flexibility, and sometimes it's easy to sort of get lost a bit, but we are definitely here to help all the time.
So you can orchestrate the orchestrator.
That's right. Yeah, you can.
Step functions.
Yes, an inception of orchestration. Yeah, definitely in many different ways. Yeah.
I see. All right. Thank you for the answer. Let's read the question from Federico. What is, if any, the trade-off between using low-level coding and the high-level services you've shown us today?
Well, I think it depends on your expertise. I think using tools like Glue Studio and DataBrew makes the development experience much faster, especially if you don't know how to write code. Okay, and especially Glue Studio, it's a very good starting point for your code. Okay, because as we've seen, Glue Studio actually creates a script for you that you can actually then go and modify as much as you like. So you can start writing your code with Glue Studio and then modify the code. So as a boilerplate kickstarting process can be very, very useful. And of course, if you're very experienced, if you know how to write code, once you know how to write code, you can actually optimize as much as you like, and go really down into the details of your code. So Glue Studio, Glue DataBrew actually are aimed at different personas. Usually we don't see people who can actually write code using Glue DataBrew, although it can be used, of course. We see people who can write code starting their processes using Glue Studio. Okay, so the trade-off basically is Glue Studio and DataBrew allow you to write complex data pipelines, even if you're not an expert in writing codes. Okay, at the end of the day, the processing and the orchestration, as we've seen, are pretty much the same from the data engineering point of view. So that side of things pretty much stays the same.
Thank you, Francesco. Let me ask a follow-up question then. In case you're using Glue and you're defining some custom transform functions, then in your demonstration, the signature of the method was injecting a Glue context object, and
Yes.
it was generating in the end a code that was instrumented with a bunch of imports that are specific to Glue. And my question is, how can you make this code portable with all of those dependencies?
Okay, there are two ways. First of all, you don't have to use those dependencies; they are there by default, but you can remove them. So, for example, you can have a Spark environment without using the Glue context, for example. Okay, so you can do that, and you can export your code into a standard Spark environment. Glue comes with its own ETL library, as you've seen, obviously. and that you can use within Glue. That gives you loads of a lot of functionality. So you can have Glue can utilize the concept of dynamic frame, which is an extension of the standard Spark data frame. Okay, which allows you to use many transforms, such as relationalize, such as resolve choice, for example. But you don't have to use them. Okay, so what you, as I said again, you can start with the code that's provided by Glue Studio, and then you can modify it very quickly and easily to actually export it into another Spark environment. But something we haven't touched today because we didn't have time is the Eta library provided by Glue. Okay. It's an open source library, by the way. You can actually download it onto your local environment, and you can develop Glue code using your standard, for example, PyCharm, for example, your standard, or IntelliJ IDEA. You can use your own IDE and then publish the code in the Glue environment. So very open again. You don't have to. Yeah. It would be nice to actually do a deep dive on the ETL Glue library because it's really rich in feature, and it makes, if you know how to code, if you know your way around, then makes it very easy to and very powerful to process data quickly.
Yeah. Okay, I think this is one last question, that is, if you want to implement ETL jobs visually, we have seen that all of the products, Glue Studio and is already offering this visual UI for building ETL jobs, but then DataBrew is also doing the same in the project section. And the last one, Data Wrangler in Sagemaker, is also offering a UI tool for building those ETL jobs. Then what are the, want to use one or the other? Is it the choice based on whether you want to be like a machine learning use case, or it's a more data traditional use case? This is what you mentioned, or is there other considerations when deciding which one to use? Because now we have three options.
Yeah, that's right. I think if you want to do a more standard data engineering task, then I think Glue Studio is it's usually the tool that data engineers use to process data and to make it available, say, to data scientists or data analysts that can then process it using either Glue DataBrew or Glue Sagemaker. Okay, so I see Glue Studio in a way as a tool to build the foundation of your data platform. And then at a higher level, you can use, for example, Sagemaker Data Wrangler if you're a data scientist that already uses Sagemaker to build machine learning pipelines. Okay, so again, it's the choice. It really depends on the kind of user you are, how experienced you are, and how used you are to the different tools. So we see many machine learning practitioners that use SageMakers, and it's very nice to have a SageMaker Data Wrangler because that allows them to do a full pipeline within SageMaker itself without actually going using other tools like, for example, DataBrew or Studio. Okay, it's really a matter of choice. So I would say Glue Studio for your standard data engineering, data preparation tasks, and then for higher level usage or analysis, I would go for DataBrew or SageMaker Data Wrangler. There's definitely an overlap of features. That can happen quite often for AWS services. Because we want to provide the most flexibility to users. It can also get sometimes confusing, and we understand that, but we like to give users the choice. And every time we put out a new feature or new services, because we have customers asking for it. So it's definitely we see users implementing different use cases all the time.
So I guess with all of those automation services in place, at least the data engineer has the responsibility of deciding which one to use.
Yes, that's right. Yeah, absolutely. Yeah. To be honest with you, I wouldn't use SageMaker Data Wrangler to process petabytes of data, for example. I would go for the more industrialized features of Glue in general. So that can be another pointer to which one to use when.
Yeah. There's another question that is about the advantages in terms of performances of using Wrangler versus Boto3.
Okay, that's interesting. Okay, they all work in memory. So basically, again, it really depends on the kind of instance that how much memory you have. Okay, and and that's for if you use them within a let's say within a notebook. So it really depends on the kind of infrastructure that you have. So Boto3 use for in general, Boto3 is the Python SDK for AWS for all services, not just for Glue or for Athena, for example. So for all services. And you can use Boto3 to automate processes, for example, or even just to start an instance or to start a cluster or make calls, API calls to different services. If you use it for data science, like we have seen, it really depends on the machine that you're using. And, so, for example, the example I ran was on my laptop. It doesn't have that much memory. So if you want to load a huge data frame within the machine, you can encounter some performance issues. And so running big workloads on your PC is not recommended. I recommend moving on to EC2 instances, for example, and run notebooks there. So it's not really a matter of which SDK you use. It depends on the kind of infrastructure that you use to run your processes.
Right. So it's both more of an interface for interacting with the services in the cloud in AWS. While if I import AWS Wrangler as SDK, then the computation will happen in the same machine where I'm importing the library.
Okay, so what I did earlier, for example, the query that I did against Athena, basically I submitted the query to Athena. So the process was actually run on a remote engine on Athena on AWS. But then the data is actually returned to your client as a data frame. Okay, that's loaded in memory. So that's what I was referring to. Yeah.
Okay, makes sense. And can you actually use it inside the Lambda function or inside other, if I create an EC2 machine or like a Jupyter server in SageMaker, then I can import the AWS Wrangler library and just use it in the cloud?
Yes. Well, yeah, it's just a standard Python library. Yeah, you can use it anywhere you like. That's why it's so powerful. Yeah. Actually, many customers use it for that, so they incorporate it within Lambda, and the Lambda might be the backend, say, for an API service, so it becomes very powerful. Yeah.
Good. All right. Let's see if there are extra additional questions. Doesn't seem like. So I think that that's it for tonight. I want to
Thank you
for the great inspiring talk and for answering all of our questions. I want to remind everybody that the recording will be available on our YouTube channel, and Francesco will share with us the slides as well. And as soon as we have the slides, we will publish them on our slide share account as well. Those are the contacts of Francesco if you want to reach him. And yeah, that's it. Thank you very much. And see you at the next